is like you want it is real. We can't just like compare what is right? So you must always convert it into the CM forms. Right? Okay. So then for example of information now. So you know that that information so the environment becomes CM to N to TM.
Yes.
You remember what it is? Like
One
is what? Okay.
Oh, Chloe, any questions about your redox reactions?
And then from to here,
Awesome.
yeah. So if you ever forget like what is not CN, KN, right? You just amplify on multiply.
Look through, what are the 4 ways that you can define a redox reaction?
You know why, right?
Yeah.
Enzyme that's right. We did it on the reason. Then get really hard area to be. Then the first question, we never do the first question. It's on, the first part, which is like on the direct. Yeah. You know the third one, which is like your really usual, like the idea of like very nicely something is good. Yes. This is the first usage.
Now, Chloe, look at the screen. Look at the first one. Which one is the oxidation and which one is the reduction? Why? Yes. Okay. So this one is quite straightforward. Gains oxygen. So who is reduced? And how do you explain it? Okay, so this one is quite obvious. So this is your reduction, and that was your oxidation. So who is the oxidizing agent and who is the reducing agent? What's the compound called? Oh, okay, this one you have to know the name. If it's going to come out sooner or later, maybe not. Yep. Okay, so carbon monoxide is the what agent? Yes, good. So of course, the oxidizing agent is the other guy. Second one. Where's the oxidation? Why?
Loses electrons.
You check what's the definition for oxidation? Is it loses electron? Is it? It is right. It is right. But did this guy lose electrons? From here to here, Did it lose electrons? The charge has become less positive now. How did it become less positive? This is 3 plus, right? This is 0, 0, let me just put it in. How to get 3 plus to 0? By it does so by gaining electrons. Remember, electrons are negative. So actually, it has gained electrons now. So try not to be careless about this. I mean, can you follow the logic? Electrons are negative. Right, so how? Oxidation or reduction? Well, you can look at your definition. Yes, good. So who is oxidized? Okay, good. Now, of course, make sure you realize that this guy has lost electrons. 3 electrons. That's how you become 3 plus. Okay, so this oxidation. Come, so who is the oxidizing agent? Make sure you mention the whole thing, Fe3 plus. Okay, so obviously this this guy is the reducing agent. But how do you determine who is oxidizing agent and who is reducing agent? Was it? Well, you can't write like that in the exam. Now it's very simple. You just say that reducing agent is oxidized. Okay, from Al to Al3 plus. And oxidizing agent is reduced from Fe3 plus to Fe. That's how you explain it. Okay. Just to be careless, that's all. It's easy to be careless. Okay, now but before I give you the worksheet, how about now? This is easier when you look at oxygen. But what if we all look at oxidation state? You will get the same answers, no? You still get the same answers. But sometimes the question wants you to look at oxidation state. So therefore, I have to determine the oxidation state for every guy. 1, 2, 3, 4, 5, 6, 7. All 7 elements on left and right hand side. Yep. One by one. The which one? ON. Yeah, ON. Oxidation state or oxidation number. Determine 0 first. Who has 0? You need to look at your 7 rules. Fe design. Good. It's element, right? So 0. Who? Yeah. C, this or this? Left or right? CO. Why? Is it an element by itself? This is a compound. So if you have a compound, by right, they cannot be 0. Okay, either C or O cannot be 0. I mean, so what's the, let's look at your 7 rules. What's the second rule? Redox. Yeah, I'm asking her about the oxidation numbers. Or should be ON. I wrote OA. The second rule is about hydrogen. Any hydrogens here? No, Then look at third rule. What's the third rule about? Yep. What's the value for oxygen? So very easy. All -2 because none of them are peroxides. And then work out the rest. Look at rule number 4. Does it apply? Not really. Rule number 5, does it apply? Then you have to use rule number 6. What's rule number 6? For oxidation number. Is that rule number 6? I thought that's rule number 5. Yep, good. So this one should be oxygen is -2, so carbon should be +2. Right, +2 minus 2 is 0 because the charge of CO is 0. How about this carbon? Yes, good. Remember, because of this subscript here, you have to do your algebra. C plus 2O equals to 0 because the charge is 0. And O, you already know that it's -2. No. All right, so just solve for carbon, then you get +4. Okay, Chloe? All right, so this +4, carbon. How about iron here? Yeah, oxidation number. Yes, make sure you have the plus in front, +3. How do I know? Same thing, you work out your algebra. 2Fe plus 3 oxygen equals to 0. And oxygen, you already established it is -2. Therefore, just solve for Fe. You should get +3. Okay. Okay, so same thing. Now, once you have all the ON, it's quite easy. Look at iron. +3 becomes 0, no? So there's a reduction in ON, and that means this is a reduction. So who has oxidized? Hopefully you can tell it's carbon. All right, +2 to +4. So carbon has increased in ON, therefore carbon has oxidized. But you notice oxygen, there's no change, -2, -2, -2. Okay, so that's how you use ON. But let's look at the other one. How about if I use ON for the second equation? Who has 0? Good. Who else has 0? Okay, remember their elements. Yes, very easy. Because the charge actually translates, the charge itself translates to the ON. And this guy?
+3.
Yep. And then by now, I think it's quite easy to tell. Aluminium, compare aluminium with aluminium. 0 to +3. So for your explanation, you write ON increases, therefore oxidation. Okay, for this one, likewise, ON decreases, therefore reduction. Okay, that's the explanation using ON. Okay, thinking, Chloe, right? Yeah, piece of cake. Okay, since you are not familiar with it now, come try this out. Be careful with the first one. You see the word hydrogen peroxide is already there. They already used the word peroxide. Hopefully that rings a bell. You look at oxygen. I mean, since they didn't specify, the easiest way is to look at oxygen and hydrogen first. If that doesn't work, only then you look at electrons or oxidation number. Which one? Number one. Oh no, that's where coming thing. Look at the screen. H2O2, what does it become? If I want to pair them out, probably this would be a good pair, right? Obviously, you can't pair the other one because the other one has I inside. What has happened to H2O2? It becomes H2O. What has it lose or gain or whatever? Lose what? Lose what? Are you sure? Okay, good. Yeah, it does. Loses oxygen somehow. Good.
Yeah, I'm gonna use ON, remember?
Oh, you want to do it the hard way? Also can.
No, I thought I have to use this.
But they didn't specify, right? Did they? No, right? If they didn't, then you can use this. But be careful, there are some questions that we specify one. Oh, once I know that's reduction, actually I don't even need to do no. I immediately know the other one, the other pair must be oxidation. But humor yourself. How do you know it's oxidation, the other pair? Hi become I2. What has happened? Yes, good. Loses hydrogen. So that's how you explain. So we can see.
It's a redox reaction.
Yes, because it contains both reduction and oxidation. If you want to be complete in your answer. Okay. Yes, you're right. But of course, you have to explain. How will you explain? Mhm. Mhm. Yep. Okay, good. Good. That's good enough. But you can also explain that H2O2 has reduced, itself has reduced to become H2O. So either explanation is fine. Yeah.
there's no electron in here, then
If there's no what,
electron.
you mean for what, 2C? Sorry, which question is that? Oh, cannot use electrons. But you can't see the electrons, no? Are they obvious? You actually you can, but I don't want to go through that step. you must still go through ON. Hey, but thinking or even for Chloe, look at this 2C. This one, right? You're referring to this one, right?
Right.
Yeah, I think that was a typo. It's actually question 2 already. But how do I pair? There's a problem, no? Do you notice there are 3 products? So you have to think clearly how to pair. Copper pair with copper, right? Makes sense, huh? This one pair with who? Now, the trick is this. You try not to pair oxygen and oxygen, hydrogen and hydrogen, because they can move around. That means you pair other elements that do not have oxygen and hydrogen. So it makes sense to pair this guy with this guy. All right, you emphasize on the nitrogen, okay? Not oxygen and hydrogen. I think by now you should be able to tell who is oxidized, who is reduced. I hope you can tell. Can see, Chloe? Should be quite visible by now.
So K is plus.
Sorry.
K is plus 1.
K is plus 1, yes. Remember, it's group 1.
Only ground got to group 3.
Group 1, group 2, group 3, yeah. But even group 3, you've got to be careful also. Usually that's correct. Usually.
So this will be BR.
Because for part A, there's no hydrogen, no oxygen, so no choice. You should use ON.
Is it?
Br2 is the oxidizing agent. Don't just write Br. Make sure you write the whole reactant. Reducing agent. Need help, Chloe? 2A. Or 2A, you have to use ON because there's no oxygen and hydrogen.
So it's -6 plus 3. CO2 minus 2 minus 4 plus 4.
But main thing for 2B, oxygen is there, so you can make use of oxygen rather than working out ON.
Yeah.
You can work out ON if you want to, right? You want to practice, sure, go ahead. But you can also look at oxygen. Yeah, usually it's easier. Which one? Which one cannot do? 2A. Okay, come. I say you have to do ON, no choice. Can you find ON 0? Yes, good. How about the ON for K? K. Remember, K is in group. And this one, no choice. You have to. You can refer periodic table, but it's a waste of time, no? So K is group 1. So automatically is +1. +1. So then what is the ON for I? No, because it's Ki. K is +1, right? So I must be -1. They must balance each other. +1 balances -1. ON of VR. K is +1 -1. Huh? So right now the ON first.
So you said NH3 is +1, right? H is +1.
Yes.
Then N is what? -1. Alright, I split by 3.
Yeah, that's the problem. You must remember to take the coefficient into account, the subscript into account.
So -1 divided by 3. I thought it would be a decimal.
Okay, come. Write your equation. Think. If I write my equation up, how does it look like? Correct? This is the equation, right? H is +1, correct? So if I solve for n, it would be -3. 3. Okay, don't be careless. You should not get a fraction. Anytime you get a fraction, better redo your calculations. O levels have no fractions.
So N is oxidation. Is ongoing oxidation. C is reducing reduction. 3 CuO is the oxidizing agent. Oxidizing agent. Then 2NH3 is the reducing agents. Let's see this.
Oh, so you work out ON as well. Oh, okay, good for you.
That one I don't know if I remember. It's a hydrogen one because it's opposite.
Yeah.
That's 4. H3 is so the rows is NH3, because NH is negative.
Negative?
3.
Yeah.
So NH3 with nitrogen with oxidation state of negative.
Oxidation state. There's no oxidization. Spell correctly. This one is tough. This one you have to work out the ON.
Transform. We don't care about 2 minus, or do we need to?
Oh, what's rule number 7?
Oh, okay. So it's negative dou
How, Chloe? Okay, you have
3C for 2.
three, number 3.
Mm.
Oh, okay. 3C. What are you looking for? ON. No, the thing is, remember C is carbon, which is the element itself. So ON for carbon should be 0, right? And then, of course, for this one, I can also pair them up, no? This pair with this pair with this. And then you can tell that this has gained oxygen and this one has lost oxygen. Without using ON, you can also work like that. But you have to pair correctly, of course.
So it's B.
What's the ON?
Of what? B.
Yeah.
N is +4 to +5, so it's oxidizing.
Yeah. Good.
Isn't there other thing?
Others, what do you mean? Which others?
I saw the others. Oh yeah.
CO2 and SO3.
Yeah.
Did you work out the oxidation number? Yeah. Is there a change in the ON? No. That you work out already, right? And you realize that there's no change in the ON. So that means it's not an oxidation.
I can't. I thought you were put reduction inside, right?
No.
ON.
This one, no need, because you can see, right, what has happened to NH3? NH3 lost hydrogen, right? Then this one has lost oxygen, right? So no need to do ON already. Iron is what?
Yes.
Yes.
So it's from Fe to Fe2 plus.
Which one? Let me see. Iron to iron 2 plus, yeah. Yeah, lose electron.
So it's
Yes. Yeah.
Because the Fe3 plus the Fe this reaction plus lose electron. Again, the ammonia. Low, so NH3 plus. NH3, no, NH4.
They say ammonia. Ammonia is simply NH3.
NH4 plus 1. Plus 1. And decreasing oxidation state. Reduction. And increase in oxidation state. Yes. So it's B. Which one have it? Yeah. So this is when try. Yeah, good. So. Reactions can know oxidations too.
For what? NO2? What did you write here? +4, +2, -3, +1. Yeah, they're all correct one. So which one has the lowest number? +4, +2, -3, or +1?
3.
Oh, yeah. So the answer is the nitrogen in NH3. So yeah, for the next question is trickier. This one you have to work out the ON for everything. Later I'll tell you why. This one you cannot use gain or loss of oxygen.
Both gain.
Where?
High gain.
Both gain.
Is it?
No. You know, for this kind of question, you cannot use your gain or loss of oxygen or hydrogen anymore. The reason is because they are ions. But how to see electrons? You can see electrons. What's the number of electrons for H2O? You can't really tell, right? So use ON. Like OH minus, you have OH as a whole, no? But which one has more electrons? You can't tell as well.
So I use hydrogen rule.
You use the ON rule, hydrogen rule, yep. Because there's no hydride. Or for the matter, there's no peroxide. Yes. And oxygen rule. So.
O is including oxidation state.
Oh, did it? What's the ON for O on the left and ON for O on the right?
H and H. Yeah, H.
What's the ON for H on the left and on the right?
0 to +1.
But where do you find 0? How come how come there's something?
Oh, it's +1.
Yes. Never mind, you need more practice, that's one.
It's +1 +1 to +1. So it's same.
Yeah, so this is not a redox at all. Oh, is it?
But the simpler one.
Simpler version.
O2 loses electrons. And we loses oxygen. Hence its reduction. Then energy is gain electron. I mean gain oxygen.
You're more interested in Mg, yeah? You're not interested in O2.
So it's oxidized. Energy is oxidized.
This one, then you can look at your electrons since you're so you like electrons so much.
Okay. Isn't Ag also gain electrons?
A what?
Ag plus.
Oh, yes.
So it is not a redox reaction.
It gains electrons, huh?
Yeah.
So is it reduced or oxidized?
It gains electrons, so it's reduced.
Yeah, so it's reduced, huh?
But Pb also gain electron dot.
Pb, think carefully. Pb become Pb2 plus, huh?
Just minus.
Probably didn't see clearly. Pb become Pb2 plus, huh?
Just the pre
Green, huh? Oh, okay, lah. Which one? Which one? A, B, or C? Oh, okay. Did you work out everything? Plus 4. Plus 4. Any change? This is -2. This is also -2. This is +4. This is +4. Yeah, no change. It's not a redox. It's not oxidation reduction. This one +4 to yes +5. So +4 to +5 is increase, right? So that is an oxidation. So this one is oxidation. But this one +6 to is it -6?
No, plus 6.
Yeah, +6 to +6. So no change, huh? Okay, so it's not redox. I maintain. Interesting.
This is how you repeated the question. I already did it before.
Oh, then you just copy the answer, then you should get it right. Right? Na.
That's why. So gain increase in oxidation state.
Good. So
So
oxidation and reduction. Yep.
the neither is just in. Okay. Magnesium metal is so by some state. I need to be the as it to one photon minus okay. That's the reactions of great precipitate of iron and colors iron of burn iron reaction. Three is N3. No, it's nitrogen.
What is nitrogen? Yeah. What is nitrogen?
So for me,
Nitrogen is N. No?
that's N.
E. Okay. How did they write it first? You have to look at the question carefully. Nitrogen to ammonia. So by right, if they put it like that, you can't just write N because nitrogen is in the form of a gas. So it would be in the form of molecule N2. Ammonia, you have to remember the formula. Yeah. Can Step 4 must remember it.
A great precipitate of Fe. So Fe is what? Solid.
Solid precipitate means solid, okay.
Sulfate soluble except for is it Chinese language? Barium chloride that. So this one is not. So it's
It is.
AQ. Energy as opposed to AQ then. Okay. So it's balance. It's balanced.
Balance, okay.
So I only have Mg plus Fe2 plus SO42 minus Mg2 plus SO42 minus plus Fe. So it's the answer for this one A.
Chlorine to hydrogen chloride. Is it a reduction? Yes, it is. But they ask it's not an example, no?
Agent. So they want me to use the ionic question.
Not necessary. Can if you can.
Electron.
Yeah, that's your favorite lah. Oh yeah, electrons are the hardest to see.
Neutral.
Especially when everything is neutral.
Two plus to Fe. You gain also. Next one you can
Cannot be right.
and that means gain oxygen lines. And you lose like oxygen line a bit. Can you have
This one is not so direct,
just oxidation state?
Yeah, just use oxidation state.
Oh,
If you're not sure, just use ON.
FeSO4, so it's -2. So it's -8
Who is -8?
O4, like total -8. Also -2.
But we don't look at the whole thing. We look at individual elements only. Individual atoms.
So Mg is +2. So -2 + 2, S is 0.
Cannot be right. You have to account for the coefficient.
8 + 2 + 6. So
Good.
Fe is don't know what.
Hmm?
Fe like 3 plus
Fe by itself.
FeSO4.
Oh,
Fe is +3.
what is the charge for SO4?
4. 2 -
So what's the charge for Fe then? Yeah. So
That's this. So -8 + 2 + 6 is also. So selflessly, Fe loses, decrease in oxidation states. So that's reduction. Wow. Mg increase oxidation state was oxidizing. So it's Mg that oxidize. And also FeSO4 is oxidizing agent, right?
which one is oxidizing agent?
FeSO4. So you're saying in terms of change concentration, it oxidized Mg to MgSO4 from oxidation state of 0 to +2.
What's the explanation again?
FeSO4 is the oxidizing agent. It oxidizes MgO to MgSO4 from oxidation state of 0 to +2.
Let me see again. Mg to MgO4.
Is there
Okay, can.
in the presence of ultraviolet mercury chloride. Mercury is
They put no Bing. They put mercury. What's that? That stroke represents what?
+1
Yeah, they already told you it's +1.
symbol.
Oh, okay. Okay. Have fun finding it. It is, but it's not obvious.
G.
Okay, good.
It's H3 plus GCl. Okay. Comes mercury. Okay. I'm gonna write it back. It's just not there.
Like you can ignore.
Okay, there's HgCl 2. H2 plus H2 plus Cl. So it's H3Cl2 plus mercury Hg. So mercury is liquid, right?
Good that you remember.
So HgCl is what? H2.
Did you write any water inside at all?
No. So it's just solid.
Yeah.
Then HgCl2 is solid.
Yep.
Okay. Balance equation.
Balance or not? Check.
2. Then balance. Okay. If the material I oxidize or reduce in this reaction, okay. 0. 0 is not let's try -1.
Which rule is this?
If
Okay, good.
so what's that? This is -1. So Hg increase
And
0.
so increase and decrease
Increase and decrease.
at the same time. And this can come up for you.
So what do I do?
Oh, what do you do? So it's both oxidize and reduce.
Oh.
Which one? Last one. Oxidize, reduce, or neither. Okay, well, there's no hydrogen, oxygen inside, so you look at ON. ON for any. Good. ON for any here. It cannot be 0, right? It's NaBr. Check out your rule number 5. Is 5 or 4? I think it's 5, right? Yeah, Chloe had to remember Na is group 1. Group 1 is +1. So 0 to +1. Oxidize or reduce. 0 to +1. Yeah, because it's an increase in ON, right? Yeah, so it's oxidized.
So 0 in the redox reaction. Is it redox reaction?
It is still a redox, yes. Sorry? Part C. NH3 to N2. NH3 become N2. You can see the H, right? So it has lost H. Correct? Lost H means oxidize or reduce. Oxidize, okay, so part C should be oxidize. Done already. Oh, great.
Both increase and decrease, so it's both reduction and
Almost, but I want your writing to be very clear. Increase to +2 in
HCl2.
Yes, and decrease to 0 in How to write iron sulfate? Chloe, this one you really must know. What's the 2 here represent, Chloe? It means your iron is in a form of 2+. Okay, it is 2, so it means 2+. But what's the formula for sulfate, Chloe? And sulfate, you need to remember it's an ion, so it's 2-. This one, no choice, you have to remember it's 2-. But together, they balance each other. Yes. Okay, got to be clear about all these things right now. How? Anything? Too easy, yeah? No. But okay lah, I see you're getting the hang of it.
Yeah. There's nothing else?
Oh no, I give you, since you're so capable, I give you the difficult ones. Hey, come on, Redox is easy. Right. Oh, at least it's easier than a lot of other topics.
It is. Then, first chapter.
What is first
living
chapter?
techniques.
Which first chapter? You mean experimental techniques, huh? Oh, that one you had problem with, right?
Hate chapter.
Oh, that's because you were not here at that time.
Really hate that chapter.
But that gives you a bit more practice for Redox. That's when you combine Redox with more concept.
Oh my god, oh, so no touching already.
Oh, yeah. Huh? Oh, correct. Time to revise your moves. How are you okay? They already used the word solution, so it must be something dissolved in water. All right. So what has happened? Magnesium is Mg, and then it encounters this iron sulfate. What does it give you? Gray precipitate of iron, meaning Fe alone. So what is left? What's the other compound? The other product? Magnesium, but we also have something else, right? From the left-hand side. Yeah, so the colorless solution is magnesium sulfate, aqueous. Oh, you can getting bored already.
Okay. Oh,
Okay, come. You can skip the first one for now. Yeah. This one you have to remember because SO4 is 2 minus, Mg, group 2, right? Must be 2 plus, so they balance each other. Okay, add in the state symbols.
Precipitate is in what form?
Come through, you must write down somewhere. Once you see the word precipitate, 100% it must be solid.
Page of the component.
Mm.
The thing is like D.
Hold on, let me double check. 13 actions and operations. Oh, yeah. Expect this sort of questions for MCQ.
Looks like redox reactions.
It looks like, right, but it's not. Do you even work out the ON? You did, right?
Yeah, it's like I asked you to confirm.
Mm.
But maybe I did it wrongly, that's right.
This one is difficult.
That was like a new problem. Where will I know this? Okay. Does it even have anything to do with redox reaction?
Let me see.
Mm.
To think about it, not really, no. Not really.
Okay. Flying water is the better problem now.
But you should still be able to answer this question.
Yeah. But I want to only. Isn't that for metals?
Metals?
Acid.
But
What?
for you, you have to broaden your definition. It's not just acid, but what are these two gases? Do you remember something about them? So they will have the same properties as acids when waters are around.
Slightly soluble in water.
Mm-hmm.
So it's not insoluble in water, right?
Mm-hmm. Okay, yeah.
There we go. The dechlorized acidic potassium. Is it the K?
KMNO4.
Oh yeah. Remember
Remember the test for gases?
that one is for what?
Which one? What's the test for? Which gas?
Carbon dioxide. Okay, so it's not because PO2 is not. So it's C. Right. That's possible, right? This is cancellation.
Yeah. But expect this sort of questions.
I think undergoes reduction.
Should be easy.
Yes. Because it gains electron. Okay. So it's close to electrons. That's the four. Plus one minus one. H2. So air O SO for H2SO4 is what? O is -2.
Yes.
-8. That's 7. And it is. That's my turn.
Okay. Yep. Michelle, remember any?
6. So as if we reduce the oxidation state. And it is the same one. So it is not a redox reaction. So it just 0 minus plus 2 H2 0. So energy increase in oxidation state. And there's no changes clear, right? So also kind of. And that's the out of really changes.
CL doesn't change, but who changes?
H.
Yes.
H also increase in oxidation state now.
Good. Yep.
So if not a redox reaction also.
No, it's a
It will
redox.
not increase, it will just decrease. Yeah. So that's wrong. Okay. The answer is why A is not?
Who said? Why do you say A is not?
What is it your nicht?
No, Chloe. You misunderstood the question. Let's look at this again. Make sure you get this right. This is a bit confusing, I know, but you have to understand the instructions there. So what's on the left-hand side? What's the reactant? Based on the words mercury chloride, right? Correct. What's the formula for mercury 1 chloride? Hg. No, mercury 1 is Hg plus. What's the chloride ion? No, chloride by itself is always minus, and they balance each other. So therefore, the formula is HgCl. But look at mercury 2 chloride. Mercury 2 chloride means my mercury is Hg 2 plus, right? Chloride is still Cl minus. Is always Cl minus. So I cannot write it like that because this is 2 plus, this one minus. So how should I write it? How to balance? Yes, good. And then it also forms mercury. So this is the product. This is also the product. And this is the reactant. Then my reaction should be written like this. Reactant on the left, products on the right. Then you balance it. Yeah, looking how? Figure already, right? Why B cannot? Come, Ming. This is a compound, right? And it's ionic compound, obviously. What's the charge of silver? Yeah, +1, right? So that means silver is silver plus, iodide is minus. So what's the ON?
Okay.
Oh. ON of silver is +1, iodine -1.
Okay, quite same thing, no change.
Yeah, no change.
They put it together.
Put in the states if you can, state symbols. Mercury, can remember the state? There are 2 liquids in the periodic table. One of them is mercury. The other one is bromine. So liquid. Mercury is liquid. The other two, not so obvious, but they are salts, right? In general, and then they didn't mention solution, they didn't mention water, so you assume they are pure salts. So that, in general, salts are solid.
It's O is -6, K is +1, so
O is -6.
K out is +5.
Yes. Possible. Keep that in mind. It's possible for CR.
H is +1. That's fine.
Mhm.
Alright. Okay, how does chlorine change? It's from 0 to -1. So it decrease in oxidation state from
Is okay oxidized already. This one is difficult. It will come out very rarely for you, but do you work out the oxidation states? There's no hydrogen or oxygen, so you have to work out the ON. Come work out the ON. Yeah.
decrease and increase.
Yes.
Increase and decrease in oxidation state
This has a higher chance of coming out for you.
from 0 to +5 in case ClO3. So it's in KCl, 5 KCl. Okay. Wait. Let me write the KCl first. Okay, so so they
This is OS from 0 to +1. You really see clearly. KCl. What is this? Just to be sure, there's some squiggle here. What is this?
5 KCl.
Oh, 5 KCl. Okay, actually you can ignore the 5. Just put KCl, that's fine enough, right? But of course, you have to be super clear. You write from 0 in Cl2, from 0 in Cl2. Where? Where? Oh, okay, no.
And we will say next.
Don't be careless, Chloe. Don't be careless. Mercury is an element. Yeah, 0. This one. Don't be careless.
0.
No. You already wrote. Here is -1. You have 2 Cl, right? So this should be. Yeah, +2. Don't be careless.
A, ClO3 has also been reduced from 3 Cl2 to 5 KCl.
You can leave out the 3 or the 5 in front. I mean, even though it's not technically wrong, but some people don't like to see all those coefficients. Yeah, I can't even see the 5 clearly.
Didn't we really do this?
Yeah, you did. Just copy and paste.
I think the first question already.
Yeah.
Okay. Cl in this reaction. Wait. We're going to have a Cl oxidation state. Wait. Oxidation state in 3 Cl2.
I think we'll, for part C, try to generalize a bit. You don't need to include the numbers from 0 to what or what to what. But basically, you want to explain what, in general, what is a disproportionation reaction.
So it's just
How to explain? I'm telling her already. But Chloe, look carefully. Where's your ON? This is +1, mercury. Then here is an increase in ON, no? But at the same time, from +1, it is also reduced to 0, no? So this is a trick question that comes up once in a long while for you. Basically, the mercury is oxidized to this in HgCl2, and the mercury is reduced to Hg in the Hg metal. So it's both oxidized and reduced. It is possible.
it's both reduced and oxidized. Yeah.
So what do you write for disproportionation reaction?
I'll leave that. I think it's general.
Yeah, general.
Okay. I didn't write anything.
Not general enough.
Not general.
It means because in part 2 you already specify chlorine oxidized from what to what, reduced from what to what. So for part C, part 3, you say that an element is both oxidized and reduced.
Cl is an element.
Yeah, C is an element.
Wait, what's the element?
How? Done? Okay, can. Okay, can. So last one is come up once in a long while. But essentially, I told her the answer already. You want to write something like this. Stop. Okay, never mind. Stop. Basically, a disproportionation reaction involves the oxidation and reduction of the same elements. Okay. Okay, good. But this one comes out once in a long while. Okay, come. Okay, just pause for a while. Let me just go through the first worksheet. Some of the answers. Just make sure everything is correct. By right, it should be, unless you're careless. Okay, somehow it's not loading. Let me check the other version. But this one, okay. Yeah, because no, yeah, lock it, correct. Okay, yeah, make sure you get this right. Basically, anyway, I use the ON to explain, but of course, like I say, you can use losing oxygen or losing hydrogen to explain. And so this one I won't touch too much. So H2O2 oxidizing or reducing. Yeah, make sure oxidizing. All right. Okay, this is what you could have written, oxidize Hi to I2, but you can also say H2O2 is reduced to become H2O. Either answer is fine. Okay, guys, can you just note down H2O2? I think I said this before. It's a common reagent for both theory and practical. It can come out in practical. It's a colorless liquid. And it can dissolve in water. So in the practical, it looks just like water, no? You can't tell unless you drink it. But what else? Important is H2O2 can be both an oxidizing and reducing agent, depending on the conditions. Because it came out in the practical exam 2 years back. No, they give you a reaction to perform. I can't remember they react with what, I think KMNO4. And then you have to answer in your practical exam is H2O2 oxidizing or reducing. Don't jump straight to oxidizing. It can be reducing as well. Just look out for it. It can come up. Because it's about time to come up. 5:45. Okay, number 2, make sure you get all the answers correct. Let me just show you the answers. Okay, that should be good. Okay, can check your answers. Make sure you should get them correct. Okay, unless you need me to explain, otherwise I shall move on. Okay, number 3. Your answer should be NH3, should be. Okay, number 4. There's only one. Okay, number 5. Only one. Okay, iron to iron 2. Why is it B? What answer do you get? Yeah. Iron 3 to iron. Oh, no. Hold on. Iron to iron 2 is not an example of reduction. C is iron 3 to iron, no? So 3 plus to 0 is a reduction, right? Okay. Okay, number 6. What's the answer, Chloe? Okay, now a few things. Oh, sorry, I missed out something here. Look at number 4 again. Be very careful. This one, notice O2 become O3, right? By right, you can argue it's an oxidation, but it's not because of the ion here. Once you see an ion, then the rule, your oxygen rule doesn't apply. Same thing. O3 to O4. It looks like oxidation, but because of the -2 here, the rule doesn't apply. So be very careful. The safest, as I said, is always using ON. That is the safest. Okay, this one. Number 6, I want you to take note. This is a neutralization. The ionic equation for neutralization. And if you look closely, part B is actually a precipitation. Hopefully you remember your rules. Silver chloride. Chloe can remember the solubility rules. This is insoluble. Now, my point is precipitation and neutralization are not redox. Try to remember that. Neutralization is never a redox. Precipitation is never a redox. So maybe that can help you. A is a bit more difficult, but I won't touch on that. 7, make sure you get the answers correct. And Chloe. Okay. Okay, number 8. Number 8, make sure you get ionic equation correct. It should be this. Here. Right, Chloe, do you reduce it to ionic equation? No, right? Don't be careless also, because they ask for ionic equation. Thinking, what's the oxidizing agent? Good. Okay, so for oxidizing agent, I try to use the whole reactant. So the safest is FeSO4. So that should be the answer. It is the oxidizing agent because it oxidizes something, magnesium, from OS 0 to 2 plus. Okay, because they did ask for OS. They didn't ask for oxygen or hydrogen. Okay, number 9, I think more or less you all got it already. Make sure you get your, this is not balanced, but you should be able to balance it. I think I'm giving you the answers, right? Number 9. Meeting? All 5, Okay. Okay, any final questions for today? No one? Okay, Chloe, some of the things you got to back up, especially all the Sec 3 stuff, like iron sulfate, what's the formula? And especially this, if you see this, it means iron is 2 plus. Okay, remember that. Okay, but Chloe, just one question for you. But I don't normally assign this kind of numeral to, let's say, magnesium. Why not? Do I write magnesium bracket 2? No, why not? Okay, come, I write it out. Did you see anyone writing something like this? You see this? No, why not? Not totally true. Now, something to do with that. Which group is magnesium in? Okay, it's in group 2. So confirm it must be Mg2 plus if it becomes an ion. So there's no need to write this out. But for iron can be 2 plus or 3 plus. Can you remember? All right, so therefore they need to write this out to make sure that this is indeed iron 2 plus. But this is group 2, so 100% is 2 plus, so there's no need to write this. Which one? Part 1 or part 2? Part 1.
VI.
Yeah, VI.
Usually it's VII or what? VI.
Oh, you don't know your Roman numerals?
So?
Yeah. 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 No, it's a bit more than that. These are your Roman numerals. 1, 2, 3, 4, 5, 6, 7.
0, 8, 9, 1. Okay.
So that one is 6 or 7?
7.
7. So why 7? That's the question.
Mine's B. 6.
Good fix. Yeah, why 6?
6.
That's the question. Why did they put 6 there?
So especially need of 6. Because there's block of 6. It's colored compound. Why?
Some.
Because it's a
What's the ON?
the ON.
ON.
ON is 6 plus.
Yeah, that's the answer. That number corresponds to the ON. And for ON, you only need to know up to 7. Yeah, Chloe. Okay. Okay. All right. So yeah, that's all. Make sure don't forget all this. It's doable one as long as you're not careless. Okay. So if nothing else, then that's all for today. So I'll see you tomorrow.